So I'm the author of this book. Maybe you've seen it before. If not, it is about implementing domain-driven design. It goes beyond theory, but helps you to put into practice domain-driven design. I'm also the author of this book, Reactive Messaging Patterns with the Actor Model. It's a Scala and Akka book that basically takes the integration or the enterprise integration patterns and implements those in Akka and Scala. And my latest book, which will be out in a few weeks, is Domain-Driven Design Distilled. So a lot of people have had trouble grasping domain-driven design, in a 600 to 800 page book. So this book is meant to give you a very practical approach to using domain-driven design. To start off with, I just wanted to say that I think oftentimes we are in an industry of extremes. What do I mean by that? It seems like we kind of latch on to an idea and we take things to an extreme where we should really use things in a more moderate way. Here's an example. ACID. Everybody has come to respect that ACID transactions are something that are very useful. On the other hand, should everything be ACID? In fact, should we use XA or two-phase commit and try to make our systems be in harmony with one another in what appears to be an ACID transaction? When you think about it, what was life like? What was business like before ACID transactions? How did businesses work? People had a wooden or metal inbox on their desk where folders or papers were dropped into, and whenever that person got around to approving something or finishing some work in a workflow, it could take not only minutes, but hours or even days sometimes for transactions to be completed. So ask yourself, do we really need ACID transactions or transactional integrity around everything? Actually, everything used to be eventually consistent. And today, many things can actually be eventually consistent. Who do you think is or are the correct individuals to determine whether something can be eventually consistent or must be ACID transactionally consistent? Who do we ask? Any ideas? Who? Humans. But do we ask the programmers? Domain experts. Good. So it's really the business that knows whether something must be transactionally consistent or if it can be eventually consistent. So we ask the business. And oftentimes we can reason with the business around eventual consistency, and especially if we can show them that if we try to make something transactionally consistent, it could be a bad thing. We could actually cause failure on other transactions or our own transaction if we try to make everything in the system consistent and in harmony all at once. Here's another extreme that I see. Monolith or microservice. Oftentimes, companies will live and die by the monolith. Actually, there may not be anything wrong with a monolith in some cases, but should we be using microservices? And if we do, what is your definition of a microservice? How big is a microservice? How big is a monolith? Is there some way to find a practical balance between monolith and microservice. So oftentimes, a monolith will turn into what's called a big ball of mud. And a big ball of mud does not have to be formed over years and years of time. It can actually happen within weeks or months. This is where you have multiple domain models that should be separated, but instead are all tangled together in one place to the point where you can't even distinguish where your domain models are separate within this one monolith application, and to the point where you can't actually make logical sense of the code when considering it in the mindset or the mental model of the business experts. So a big ball of mud is not only a monolith, but it's worse than a monolith because you actually can model a monolith in a respectable way. But what about microservices? What is the size of a microservice? How many microservices should there be? Do you know what these numbers have in common? 100, 400, and 1,000. These are actually all line counts of microservices that I've seen or heard defined. Some people will say there should be no more than 100 lines of code in a microservice. There should be no more than 400 lines of code in a microservice. There should be no more than 1,000 lines of code in a microservice. Who's correct? So it's an interesting proposal. Now, someone named Fred George, who here has heard of Fred George? He's actually, many of you haven't heard of him, he's actually credited or credits himself with coming up with the idea of the modern day microservice. So he was working in monolith land for quite a long time. In fact, he says that he was working on one of the largest JEE applications on the earth, on the planet. But after that, he got into what he termed were microservices. And you can watch Fred George's presentation here on Vimeo at this URI. And what Fred George says there is that one page of code makes a good microservice. Now, if we think about pages in old terms, like what I remember, what was that? 62 lines of code? 65? Okay. What was it? 25 page? 25 line page. Okay, maybe. Anyway, it's hard to even define how big a microservice should be by this definition, because even within this room we have different definitions of what is a page of code. So, how many microservices should we have? How big should a microservice be? What I'm going to do today is give you a prescriptive approach to doing this, and one approach that you may want to consider or even use. If you look again at Fred George's definition of microservice, he says that in some of the enterprises where he has worked and created microservices, that they actually have many, even an untold number or unidentified set of services that no one even knows are running. They actually just leave them out there whether they still have any purpose or not. And Fred George says that it only costs the company about $40 a month to leave those services running, so why bother? Why bother looking? Now, to me, that's a problem. I don't like not knowing what's running. I don't like even the thought of not caring what's running because it could have consequences. Also, when we think about infrastructure, infrastructure can have a really big impact on how many microservices we want to run. Think about having a cluster of servers to run a single entity. And that is what those such as Fred George recommend. If I have 100 lines of code for a microservice, those microservices are going to need to be resilient. We're going to have to be able to recover under failure if a service fails, or various other things. How many clusters could you actually have running in an enterprise if you defined your microservices like this? So what do you think is a practical way to measure the size of a microservice? What I am going to do is talk to you about what domain-driven design offers regarding the size of microservices. And in specifically, I'm going to talk about bounded context. How many of you here are at least somewhat familiar with what a DDD bounded context is? Hey, excellent, good. Probably about half. Now, even within the microservices community, there is the use of this term, bounded context, but I want to make clear that it is not always used in the way that domain-driven design means that pattern or defines that pattern to mean. And what I'm saying by that is, again, some will say that a single entity, a single concept, such as product, let's just take the concept of a product, that product is actually in its own bounded context. Okay, it could be, but it shares no other linguistic, conceptual ideas with any other thing in your enterprise. I would say that that's questionable. So when I talk about building microservices using bounded context, I'm roughly referring to what Sam Newman describes in his book, Building Microservices. He does, in his book, talk about using true domain-driven design bounded contexts. And so what is the size of a bounded context? Any ideas? Is it just one entity? Do you know how we know what the bounded context holds? We have to ask our ubiquitous language. We can't say specifically that a bounded context has just one entity or 5 entities or 10 entities. It really depends. It depends on the ubiquitous language. And so that's the other idea that I'm promoting today is model microservices in a bounded context that is determined in size by how big the ubiquitous language is. Linguistic components are cohesive, and therefore I think that many times within a bounded context, while you can think of the components within that bounded context as being in themselves microservices and actors for that matter, we probably would not want to separate those because they have a natural cohesiveness where they collaborate together in some way. So, let's take an example. This is what I would call a fairly reasonably sized bounded context because it addresses the ubiquitous language of Scrum. And if you've looked at my Implementing Domain-Driven Design book, you're somewhat familiar with the concepts of this specific domain model. Product, backlog item, release, sprint, team, team member, and product owner. These are the concepts within the ubiquitous language of Scrum. We have a set of abstractions that represent the concepts of a Scrum-based application or a project management tool. And so if you think about a microservice as being this size, it can really be practical. But we aren't talking about creating a monolith in any way, because actually in this case, we see that we have 4 microservices or 4 bounded contexts that are interacting in some way, and each of them are addressing a specific part of the business that needs to be addressed. So we have the Agile Project Management context. That's the Scrum-based system that I spoke about. We have a different ubiquitous language for collaboration. We have an issue tracker context and an identity and access context. 4 different microservices, 4 different bounded contexts. Now, think about this for a moment. Let's add a 5th microservice into this mix and count how many entities are in each of those bounded contexts or microservices. Actually, it's 35 different entities if you were to count them. Now, how many here would like to have 35 deployed cluster units to represent your microservices, or how many of you would rather deal with 5? Can I see the vote for 5 versus 35? Okay, fair enough. I think that's a good conclusion to reach. So what I am proposing is that at least to get yourself started with microservices, use bounded context. You'll probably find that bounded context works very well in general for the long term for microservices. But if you find that you're becoming more and more comfortable with microservices over time, and you want to make smaller deployment units, that's not out of the question. But I think it's wise to start with this granularity to begin with. It's larger than one entity, but it's much, much, much smaller than a monolith. So the ubiquitous language that I am talking about is greater than entity names. A ubiquitous language is really the language that the business comes up with and that developers help the business refine in a close-knit team. And so a ubiquitous language grows, it expands, it contracts over time, but it's greater than just the entity names. It includes, from a reactive development perspective, not only the entities, but also command messages and event messages. So that's what we're going to talk about next, is the commands and events that are part of the ubiquitous language of Scrum. So we have our product entity, we have our backlog item entity. And we have a command message, and if you're thinking in terms of Akka, this would literally be a message that gets sent to the product actor. So backlog or a planned backlog item would be a case class, for example, in Scala. We create an instance of that case class. We pass the message to the product planned backlog item. Product then emits, if that is a valid command, it emits a backlog item planned domain event. This is part of your ubiquitous language. When we think about the backlog item, entity, again an actor, and we have a case class, define task. An instance of that case class is sent to backlog item, define a task, and what that backlog item emits is task-defined domain event. So this is all part of your ubiquitous language. This is all within a single microservice. Note, too, that your microservice, i.e. bounded context, owns databases. It owns an event journal. So those two events that you saw being emitted by those two different entities, those events are being saved into an event journal, which is a sequential journal of all events that have ever occurred within that microservice or bounded context. This makes up the event streams and the entire event journal for that bounded context over time. So this is what I'm talking about. You put events in the order in which they occurred. And events can also be published out to other microservices so that they can function properly. We also have what's called a query model. So this view is event sourcing, which corresponds to Akka persistence. And then we can take the events from our microservice or bounded context and create a model that is query optimized for the kinds of queries that our users and integrating services need. So again, we're talking about actors as asynchronous services, and if you will, you can actually architect your system in such a way that the actors within a single bounded context are like many microservices within. Okay? What I want to emphasize next is to never, ever, ever do this. Don't ever take a request into one perform some transaction with an entity and then send a request to another microservice, because this is trying to mimic XA, right? Except it doesn't. So if you have a failure right here, it means that your system is out of harmony, and that's a bad situation to be in. So what do we want to do? Well, this is where I agree with Fred George. Fred George talks about rapids, rivers, and ponds. Rapids. We're going to talk about rapids first. What are they? Rapids is where every single microservice in your enterprise publishes domain events. And all of those domain events go into one big bus topic, let's say. Think of it as the all topic. Everything goes in there. And then, so it kind of looks like this. We have a microservice publishing events into a topic, and each of the microservices gets every single one of those domain events. So every other microservice knows about the domain events that happen in every other microservice. However, well, first of all, this requires a high-performance bus. To make it really simple, actually a RESTful or Atom Pub kind of approach works really well. You can also use KAFKA, RabbitMQ, or something like that for the rapids, all right? And we can linger on that a little bit later. But the rivers are where the individual microservices or bounded contexts subscribe to the all topic events, and then they filter out the events that they're not interested in, and the events that they are interested in are dispatched to actors within that microservice. Like this. So the topics, service, it's a microservice in its own sense, but it's not really a bounded context. This is a technical service where domain events are flowing in and then being published out to an interested microservice, and an event is turned into a command because an event is a matter of fact. You cannot dispute that the event occurred, but the command can be rejected. So in this case, we're saying that this event translates to this command in our microservice or bounded context, and possibly this entity will accept that command. If it does, what will it do? Well, it's going to save its entity state as a series of domain events, part of your ubiquitous language, into the event store or event journal. And then the actors will emit those events back to the rapids. So you see the circle? And now, again, other microservices can take advantage of the fact that those events have occurred. Channel services may have a very, very small ubiquitous language. And here's what I'm talking about. In this case, you may have an enterprise that looks for or is interested in offers that users would like to see. Some kind of offer. Maybe it's plane fares, trips, vacation rentals, something like that. So you have an offers detector, but how do you actually make the reservation? Is the reservation part of this ubiquitous language? Or would you conclude that it's in a separate microservice, a separate ubiquitous language? Well, it really depends on your conversations with the business experts, but it could be that your ubiquitous language for channel services are much smaller, even just a very few entities. So what about reactive with microservices? We're interested in microservices being responsive, resilient, elastic, and message-driven. Responsive, in my experience, using Scala, Akka, and Play, I oftentimes see REST endpoints take a request and provide a response within 12 to 20 milliseconds time frame. So this is a very, very highly responsive environment that I'm describing. What about resilient? The interesting thing about Akka and the actor model is that when you have an exception thrown by some actor component, it's not the client that has to deal with that exception. It's the parent of the actor that throws the exception that deals with it. And the parent is the component that best understands what to do under those circumstances. So we aren't leaving it to every client, for example, of the domain model to understand what needs to happen under every situation where an exception might get thrown. Instead, the parent of that component is what deals with it, can help the system to recover quickly, even to self-heal, and then all that the client needs to understand is, was my request honored or was it not honored? If it was honored, we're good. If it wasn't honored, I can retry or offer a failure condition to the user. That's all that the client needs to understand. And the client can build a circuit breaker for retries. It can use backoff, exponential, capped backoff. Can use a lot of different approaches for retries, or it can simply offer a failure condition to the user. Elastic, well, if you haven't seen the other talks about Akka cluster and how Akka cluster is elastic, then I would say that you should watch those videos after the conference. I'm not going to linger on this, but you can actually shrink and grow a microservice on demand. Message-driven, to be clear, actors are message-driven, and the Rapids approach to publishing all events and subscribing to all events in a given system is message-driven. And I also want to talk about the nature of the throughput of the high-performance bus. We're talking about being able to, with REST, publish and subscribe to tens of thousands of events per second, and with Kafka, even hundreds of thousands, if not higher, numbers of events per second. And there's actually a RabbitMQ service that you can get from Google where you can publish, as in send and receive, 2 million messages per second. And I'm talking about 1 million in and 1 million out. So probably for a lot of us, that kind of throughput in the Rapids will probably work pretty well for us. Okay? So let's talk about how to implement microservices using Scala and Akka. And this is the distributed computing use case that I'm going to show you in this demo. What we have is, as step one, you see at the top, step one, we have an incoming command message. The command message is create a product. This is in the Scrum Agile Project Management context. So we're going to create a new Scrum product. A Scrum product in the ubiquitous language is defined as the software that we're building. That is what a Scrum product is to an Agile team using Scrum. The command comes in. We emit 2 domain events from our product, or the potential for 2 domain events. We definitely emit product created, which says that this product has been created, but if the command message also stipulated that a discussion, a collaborative forum-based discussion, should be created in addition to the product, we will also emit a discussion requested domain event. That domain event will end up in the river, or in the rapids, I should say, and then eventually into the river of the collaboration microservice, discussion requested, and a forum and discussion entity will be created in the collaboration microservice, and then a discussion started domain event will end up back in the rapids, and then it will go back to the Agile Project Management context microservice as discussion started, and the product will now have an identity that says, I have a discussion available through another microservice. So whenever our users want to have a chat about this Scrum product in particular, they can use this threaded discussion to carry that out. So let's look at the code. And what I want to show you is, first of all, in each microservice, you're going to need some sort of startup. So when you have a microservice such as the Agile Project Management context or the collaboration context or any other kind of service, you're going to need to get in touch with the rest of the microservices. And the way that you do that is you have what's called a service registry. And so as you start up, can everybody see this code? Okay. Not so good? A little bigger? Let me, where are we here? Okay, all right. So what we have is, and this is using dependency injection within Play, within the Play framework. So we're going to bind what's called a startup runner. That's really just this singleton class right here. And this startup runner is going to bind in eagerly, which means whenever the service starts up, this is going to be the first thing that happens. All right? And we register this startup module in our application conf file of Play. You can look at the details of how to do that. I won't show you right now, but it's very simple. All right? So this is the first thing that's going to happen when your service comes alive. Now, your startup runner is going to do a few things. It's going to create a topics feeder, which is going to be responsible for taking all domain events that occur in your microservice and putting those into the rapids, or that topics service. And then we're also going to start a topics reader, which will read all new domain events from the rapids and bring them in to our microservice so that we can filter and get the events that we're interested in our particular microservice. Then we create a heartbeat actor that registers this particular microservice with the service registry. It says, under this name, I provide these URIs. Okay? Just to put it simply, as you can see at the very top of this code here, I have a home URI, I have a new product URI, so this is how another service would send a request to my service to create a new Agile product, or it could be a UI that uses this. And then we can also do a query on a product through the product name. All right? So that's the kind of thing that happens, and then every few milliseconds, this actor will re-register itself with the service, which allows the service to actually move around, and it also allows the service registry to check health. The next component that I want to show you is the products controller. So this is in the Agile Project Management microservice. It is the controller that will take REST requests. So if you can make out here, I have a comment, which is a curl command. And this curl command can be used to create a new product. I'll demonstrate that in a moment. And this curl command can be used to get the state of a product by its ID. Okay? So what we're going to do is, for example, when we create a product, we're going to get the product description as JSON data from the REST request. And then we're going to get the identity for the product. The identity is going to be sent in with this command, create product. Remember, our command message is being sent in, create product, to the new product, which is an actor. We get a future back. we map the future to create product result message, and then we map that to a result, and we're going to assume that the product was created. You would have potential failure recovery in this situation. But if we have created, we're going to send a 201 created message with the location URI of where that product can be found. So if you wanted to immediately query back and ask where is this product, or what does this product look like, you could do that. Okay? So we've actually looked at service startup. We've looked at a service endpoint. Now let's look at the potential need for a process manager. A process manager is described in enterprise integration patterns and shown how to create a process manager in my book, Reactive Messaging Patterns with the Actor Model. I'm going to show you an example of this in code. So this is, as you can see here, the start forum discussion process, or the start forum, or the forum discussion starter, which is a process manager. This process manager is interested in just 3 messages. One message is start forum discussion. So as its default receive block, it's going to take a start forum discussion, and it will then create a new entity called forum, and this entity will be sent a start forum message, and internally this forum discussion starter will become a start forum discussion info listener, which is the next block down. And notice that I give this block an info, a start forum discussion info object, so that when it receives a forum started message, domain event message, it knows that it can then properly create the discussion within the forum, and then this block tells the listener to become a discussion started listener, and finally we reply back to the original sender that we started a forum discussion. All right? Now an example of an entity or a persistent actor. This is the product entity in the Agile project management context, and it's going to receive a create product command, and what will it emit? It will emit at least a product created event, and if a discussion was requested, right here, it will also emit a discussion requested domain event. This domain event will flow over through the rapids into the river of the collaboration context, and that is where this forum discussion starter process manager is going to see that domain event or a command based on that domain event, and it's going to run. So what I want to do is show you each of these services running. So I'm going to start the service registry on port 9001, and since this is in development mode, I'm just going to ping this service registry and make it start running. Then I'm going to start the rapids. This is the topics service running on port 9002. And I'm going to ping service as well. So these are two technical services. They're not really taking care of any business function. They're just taking care of service registration and pub sub, essentially. Now I'm going to go to my collaboration bounded context. This is actually a business microservice, and it's going to run on port 9003, and I'm going to ping this service so that it starts running. And now I'm going to go over to the Agile Project Management context microservice. And let me ping this service with something actually meaningful. So now the curl command that I'm running here is actually going to post to create a new product in the Agile Project Management context. And what you should look for is in the topics, you're going to see, so in the upper right corner, you're going to see a message come across. That is the domain event that fires from the Agile Project Management context. So here we go. You see the Agile PM is starting to run. We're going to get a request. Look up at the topics. You see the topics. That message was just delivered over here to the collaboration context. And we finally got back in the Agile Project Management context indication that got the domain event that we were looking for, that the discussion was started. And if you want to look in the collaboration context, to go back a ways here, you can see that the topic for all message was received. We got a collaboration discussion requested event that caused a forum and discussion entity to be created in the collaboration context through that process manager. And then the topics reader consumer said that completed successfully. And if we look back in our Agile Project Management context, we see that this discussion was started. We got a discussion started domain event, and that allowed us to marry up the discussion ID with the Agile Project Management product. Okay? All right, so you got to see an actor aggregate. Let me just show you, we're actually a little bit over time. If anybody absolutely needs to leave, feel free to do so, but I did want to show you also the CQRS part of this. CQRS stands for Command Query Responsibility Segregation, and this is where we're going to take the domain events from our own bounded context, our own microservice, and we're going to create optimal query views for how the user would want to consume the information within this microservice, for example, on a UI. So we get a tick event every so many milliseconds, and this tick event is used to read a persistence query, or to use a persistence query from Akka persistence query, and to read any new domain events that have been received into our persistence, into our event journal. And each of those is projected, each event is projected into the proper view. So now, whenever we receive a query product view, we can return a product view result object that has the view of a given Agile project management product. So this is tuned for how the user wants to view, which is different from the product aggregate or product entity, which is tuned for commands. All right? So any questions?
Regarding the rabbits, so you're putting domain defense in the rabbits.
Yep.
You're also kind of sourcing your anchors from the same domain defense. Is it introducing like kind of database coupling in there? Is it better to like kind of use a more stable event interface that you put in those rabbits? Because all consumers, once you change your internal domain,
Yeah.
upgrade.
Okay, so I think what you're asking is, in thinking about this component, should we have more specific topics?
Not specific topics, but more if you're basically sharing your data model now. If those are event sourced.
Okay, but everything that's going in here is just a JSON representation.
Got it, but as soon as you change, like add a field to your consumers, you break them.
Yeah, well, you have to take into consideration versioning of domain events or replacing domain events. So yeah, that's a thing for sure. But maybe we could take that one offline. Any other questions about this?
So regarding the bounded context,
Yep.
say for example, you have only two services in a particular bounded context that are overloaded. Do you have the flexibility of scaling only those two services, or do you have to scale the entire bounded context?
I see what you're saying. So essentially what your argument is that if I have one microservice per entity, one entity per microservice, I can scale those independently, right? So that could be one reason to break one entity out and deploy it separately, but logically, it's still part of that ubiquitous language. So I'm not necessarily saying that you should never deploy individual entities separately. You can do that, but I argue that they're still part of the same ubiquitous language. You just have a different deployment strategy. Okay?
In that case, we at Brady, we take a bounded context, and they actually have multiple services, so they're all within the same project.
Right.
So they share a domain model, but we can break them out into specific services if we want to scale them.
Right. Right. Yeah. Scaling is definitely a reason to break them out. I can't hear. I'm sorry.
In this diagram, the persistence or journaling is happening in the product, right?
Yes.
Even the view projection is also happening in the product, right
Yeah.
there, right?
The view projection is happening out of band from the product.
Okay.
So I actually have this product's views is a separate actor. Okay? Yep. And you can send a query message to that actor, and in the background, or every so many milliseconds, that actor is looking for any new interesting domain events, such as product created, discussion requested, discussion attached, right? And it's building the view from that. Okay? Any other questions?
In that case,
Go ahead, guys.
Why are you using time to subscribe to the events? Why don't you just get the events? Or why the tickers, for example?
Go ahead.
Yeah,
and
so why are you using time to subscribe?
why am I using time?
Yeah, every 5 seconds. Why that? Why don't you just subscribe to the events and get the events as they happen?
Where do you see 5 seconds? Oh, yeah, my good eye. Yeah. Oh, 2 seconds. Yeah. So actually, for practical purposes, this is for teaching, okay? But this would obviously be maybe like 10 milliseconds or 100 milliseconds or something like that. We don't want to just pound this pub sub interface is running over REST, and we don't want to just constantly pound the reader. But certainly you have to find the right threshold for reading events. Did you have another?
So in your example here, your product aggregate and your user in the same service?
Yes, they are.
And that's an example of where we would split them out, maybe put the read side in one service and the command side in another service, and then maybe put like another service as a web front end to them.
Interesting.
They can all scale in very unique ways.
Yeah, so when scalability is the thing, right, you definitely have to approach this differently. But what I'm saying is, to start out with this sort of conceptual architecture of microservices is going to greatly simplify your ability to succeed with microservices to start with. Then, as you see that individual entities or some kind of component needs to scale greater, then you can pull that one out from the one microservice and deploy it separately, but it would still logically be part of the same bounded context, same ubiquitous language. Yes.
You were talking about a service registry for all of your endpoints, so where does that go and what is the purpose of it?
So that is a technical service. It's running here, and it's in your infrastructure. It's a service that needs to run, and what it's doing is just think of it as a global map, so to speak, where I have a key value pair, and the key is the name of my service, and the value is another map that says these are the endpoints that I support, or at a minimum, it would be a key with a single value that says, here is my home location, and from there you can navigate to all my other endpoints, right? Is it a real-time what? No, it's actually, that is how anything knows that it can use the Agile project management context, or it knows that it can use the collaboration context. It's basically like a service lookup. It's where you do your service lookup. Some people call it service locator. I swear off that word because it gets me in trouble every time I use it. But it is a service registry. It's where it's sort of a central location that in itself can scale and provides the means for all other services to know where it can find a certain service, right? All right? Makes sense? Okay. I can meet outside if anybody has any other questions. Thank you for attending.